Welcome to the session on model training.
So now what we have to do is, training and testing data set contains only messages, not the numerical data. We have not yet converted into numerical data, right? So it contains only, if you check extra underscore train, you will see this as only messages, right? X underscore train contains the messages only. Okay, so you can access any message with this, with its address. So for example, this is the first message, go until this is the first message, and you can access any message. So that means get the door. Okay, so fine. So we have xtrain and xtest. So xtrain and xtest are only messages. That is a text format, right? So we have to convert this text data into a vector, so numerical data. To do that, we are going to use count vector. Okay, already we have imported count vector here, count underscore vector. So this is the count vector object. So I'll be using this particular count vector object. So already we have imported this, right? And we have created this particular object, count underscore vector. So we'll be using this particular function object, count underscore vector. In this count underscore vector, we have a method called as fit underscore transform, fit underscore transform, x underscore train. Run this. Okay, but we have to store this in some train. Give some variable here. I'll be storing this transform of data into train. So vector will be stored in train. Run this. And same way for testing data also, test is equal to count underscore vector dot transform x underscore test. Run this. Now we have both train and test. Okay, you can check what is train and what is test. Okay, so just print what is train here. So the train is sparse matrix of type class numpy dot int 64 with 55209 stored elements in the compressed sparse row matrix. Okay, remember this particular train is a sparse matrix. Okay, it contains a matrix having this many rows and columns. So 417 by 7456 means how many rows here? So total 417 rows. So it starts from 0 and will go up to 4178, and you have total 7456 columns. So what is columns and rows here? Rows are already, we have the messages, right? So messages from total message, how many messages we have? Total 4179 messages. These are the text documents. Remember, 0 to 4178 are text documents, and each column represents the unique words are represented in the columns. Remember, there are how many? 7456, total 0 to 7455. So 7456 unique words are there in this particular train. So you can see this. So for example, train, you can convert this train dot to array. Check this. You can see this. Okay, so 0 0 0 0 0 0 0 0 0 0. So this particular, this is the array train dot to array. Okay, so you can convert this particular sparse matrix. What is a sparse matrix? Sparse matrix will contain mostly zeros, and few of the values will be numbers, right? So you can see only zeros are here, we can see them, but other there are numbers inside also. Okay, this is actually train data, okay, which is actually in matrix format. Is this clear, all of you? The same thing you can do for test also. You can even convert test to array and check this. So this also having many zeros. Okay, so total how many elements are stored? It's all about 55,209 stored elements compressed. Yeah. So now you can see the features, right? In the column, generally you will see unique words. Remember, all the unique words will be represented as a column. So each column is a one unique word, so on. How many unique words we have? Total 7,456 unique words. in all the train messages. So suppose you can see the features also. Okay, how to see the features? So to see the features, we have a method called as get underscore feature names. So you can see the feature names also. So here I'll be showing you, for example, count underscore vector dot get underscore feature underscore names. Yeah, okay. Okay, so in this, so as you can see, these are all the features, right? So you can see there are some numbers combined with alphabets. And if you go on, these are all 7,456. These are all unique words. All of you, can you see this documents? These are all unique words available in this particular documents. All the documents have all these unique words. You can observe this, right? There are many. So 7,456, but we were able to see few here. So yeah, I'll be making it in comment. Okay, right. So you understood, right? What is train and what is test? Train is documents converted into SMS messages converted into numerical data, and that is that X train. X train data is converted into train. Same way X test data is converted into test. This is clear, right? So now we will be building the model, means we will be training the model. To train the model from sklearn dot, so we have a naive Bayes. So in this naive Bayes, we have different naive Bayes classifiers. So we are going to use multinomial NB. Okay, multinomial naive Bayes. Why we are going to use multinomial naive Bayes classifier? Anyone? Any guess? Why we are going to use multinomial? Why don't we use Gaussian? Please tell me. Multinomial NB. We are going to use multinomial NB. So this is a multinomial naive Bayes classifier. So yeah, we have to import this. Import. So we have imported multinomial NB. Okay, after importing multinomial NB, now we have to create an object of this particular classifier. Okay, naive underscore Bayes. So I'll be creating this particular object. This is the multinomial naive Bayes object. So naive underscore Bayes is equal to multi. So I'll be copying this. We have used Gaussian naive Bayes previously. Now we are using multinomial naive Bayes. When to use Gaussian naive Bayes and when to use multinomial naive Bayes? Anyone please tell me? Gaussian naive Bayes is generally used if the predictors are the features. Remember, predictors are features are numerical data, continuous data, then you have to use Gaussian naive Bayes. If the numerical data is a continuous data, then you have to use Gaussian naive Bayes. If the predictors or the features are text documents, then we have to use multinomial naive Bayes. Okay, here we have the features messages. Okay, the messages are text. So these are the text documents. If you are working with the text documents, then you have to use multinomial naive Bayes. So create a class object here. Okay, so after this, so now we have created the model. Now we have to train the model. Okay, we have to train the classifier on the training set. Okay, so naive dot Bayes dot fit. So for training, we have to use the fit method. Fit. So here you have to provide train. So what is train here? So this is X train converted into a vector. So this is actually count vectorized output, right? Train. And here you have to provide y underscore train. So y underscore train is already in labels 0 1s, right? So no need to convert this particular y underscore train. You have to convert only x train because it is a text format, right? So that's why I have converted this from x underscore train. We have converted this from x underscore train, right? So this is obtained from x underscore train. We have used count vectorizer to convert this text into this particular train. So this train is a matrix, sparse matrix. Okay, so now fit this model. So once you have done this, okay, now you have trained the model. Once you train the model, now you can predict. So how to predict? There is a method to predict, right? So predictions is equal to naive underscore Bayes. Here you have to predict. So method is predict method. So you use the predict method. So here the pass test x underscore test, which is converted into numerical data. We have to pass this test. Okay, now run this. Now you can check the predictions. Run this and you will see 0 0 0 1 0. These are predictions we obtained. Okay, so I'll be showing you, I'll be combining predictions. This is the predicted values, and we are going to have the actual values also. We have actual values, right? I'll be combining them and I'll be mapping them and make it as a list, okay, by using zip method. Okay, I'll be doing that. So thread list is equal to list of zip. Here you have to provide actual values and predicted values, right? So what is the actual value? Please tell me, anyone, what are the actual values? Where is actual values? Now we have predicted values, right? By passing test we got the predicted values. What are the actual values? Yeah, anyone in this class can answer. Grishma, Vaishnavi, Manasa, Sujita. So here we build the model. Now you are giving test data. This test is nothing but which is x underscore test input values, so which is converted into numerical, and we are giving this test. When you give this particular test value, you will get predicted values 0 and 1. We know 0 is ham, 1 is spam. Okay, so these values we obtain, right? So these are the predicted values for given x test values. Then what are the actual values? Can anyone please tell me what are the actual values? Y underscore test, right? Y underscore test is actual values, and here we have predicted values, right? We have to compare these two, y test and predicted values. By passing x test we got predicted values, and these predicted values must be same as the y test. Okay, so here you have to give predictions comma y underscore test. Now you can run this print thread list. Now you can see here 0 0 0 0. So means here you can say that actual value and predicted value are same. Here also actual value, predicted value. So most of the cases you can see that predicted values and actual values are same, right? So error is less, so most of the predictions are perfect. Okay, so it is predicting perfectly. You can see most of the time you see the predictions are 1 1, so there are no mismatches. Okay, I see no mismatches here. We can't identify, so actual value and predicted value are same, right? I hope you are able to understand, right? Is this clear, all of you? So I'll be keeping it in the comments. So this is clear, right? Now I'll be showing you the accuracy. Okay, so we have to evaluate the model. How to find the accuracy? Okay, so accuracy can be obtained from accuracy score and precision score. I'll be importing those methods from sklearn dot metrics import accuracy underscore score and precision underscore score. Okay, now we have accuracy score and precision score methods. We can use these two methods in order to find accuracy score and precision score. Now score is equal to, so use this method accuracy score. So accuracy score of, so here you have to provide y test and predictions, and you can run and check the score. Now we'll see this is 0.988. 98%, is the accuracy score. Okay, so means accuracy is so good. Okay, so we can do that. Now I'll be showing you one real example. Take a real example. We have x underscore test, right? X underscore test. What is the message in x underscore test? So we have messages. Now let us take some x underscore test, some point 1078, suppose some point. So this is a message. Yep, be the pretty sculpture. Okay, so this is the message. Now we need to know whether this particular message is spam message or ham message. Okay, to know that, I'll be predictions is equal to naive Bayes. This is the model. Naive Bayes is the model. So we actually name this model, and this is the name we are given. And predict. So here you have to pass the test. Okay, so I'll be passing this app by the pretty sculpture. Directly we should not send x underscore test, but x underscore test is converted to the vector, right? So that particular vector value should be passed here. So we have test, right? In the test we are going to send 107 test 1078. Run this. Now we'll be print predictions. When you print predictions you will see 0. Okay, so this is the first element in the list. Okay, 0. Now you can see that for this particular test 1078 we got 0. What is the meaning of 0? 0 means your message is spam or ham. Anyone please tell me, if you got a 0 means what? You got a spam message or ham message. And you can write a code here. If predictions of 0 is equal to 1 is equal to 0, right? Once if it is 0, then we can say that is print messages ham, else print message is spam. Now you can see that message is ham. Okay, same way change this message, some other message, take some other message, just finish bathing. Okay, 70, run this. This is spam. Okay, I'll be taking user inputs now. So take the user inputs here. So now we will ask the user. Okay, SMS 1 is equal to, so ask the user input, enter SMS message. So user will be entering the SMS message. So based on this particular message, okay, so you have to the model should classify whether the received message is a spam message or ham message. Okay, so now we have to convert this. Generally user will be providing a string. Remember, user will be giving you a string. Now this particular string must be converted into the vector. Okay, and then we have to pass that in the model. Okay, so now predict underscore SMS is equal to naive Bayes. Then here, yeah, now we have to convert this text. Okay, so this is the text message we are entering. That text message must be converted into numerical values, and these values should be passed to the model. Okay, so here I'll be using count underscore vector dot transform. So here we have to provide the SMS. Remember here, yeah, this is SMS1. Okay, the name is SMS1. Okay, so remember here we receive the text message, okay, that you type as a user. Once the this SMS1 contains a string message, that message will come here, and we'll be converting that into a vector, sparse vector, and this will be passed to the model, and the model will predict. Okay, so here it will be predict underscore SMS, right? Now we can run this. now give some message here. Okay, so you can give anything, lottery ticket available. Yeah, you can buy this. Yeah, so we missed predict, right? So you can type any message here, and you will see that the message is ham or spam. Okay, based on the message, you can get a message classification. Okay, you can do the classification of the given message as either spam or ham. Okay, simply we have to provide the inputs. It's very easy. What we have to do is we have to provide the inputs, and based on inputs it can say either spam message or ham message. Okay, is this clear, all of you? You can run this again. Spam. So this is spam, right? So prize money won with lottery, some buy this fast. So this is a spam message. So in this way you can actually predict whether the given message is a spam message or ham message.